For this project, I want to use these Lego wheels, but I want to be able to flip them around so they get even wear left and right. These are my previous EVA foam tires, and as you can see on the outside edge, the latex has worn off a lot more than the center. These are great. They chunk off when they get hit and they keep working, but when I use my magnets, they compress and I just get stuck to the ground, and I can't move. So I need a rigid tire. This is what I used in Lynx Mark II. Basically, as you can see, the outside edge is a lot more worn than the rest of the tire. And I didn't really like this one just because I had to cut each of the tires, and this edge is pretty jagged, and then gluing them wasn't very fun either. This is my design for a Lego and printed wheel and tire setup. So my main goal for this was to have a removable kind of pulley system. So I can yank this pulley out and push out the bearing on the other side, and then swap the tire around so I can get even wear on each of the corners. Just like this. And then this goes into my 3-pound Beetleweight Lynx. So start off with pushing a insert into the tire. Basically this just prevents the tire from compressing. Since I run magnets, I don't want any compression, or else the magnets will like suck it to the ground. And obviously, since magnets are get stronger the closer they get to the metal surface, it just kind of exponentially gets worse, and I can't move if they get compressed. So I put the tire on. I leave one bead kind of shy, and then the other bead obviously hangs over the edge. And then I put my wheel into here. These grooves are for the bead to sit, and eventually they'll get glued to this hub. So that goes in, and then on the back side, just kind of push it through and work it so that the bead settles in. And flip it over, do the same thing for this side. Just kind of evenly work it around. Get the bead over, and then work the bead into the groove. That looks about good. And once that's done, take the hub, the pulley side, insert I'm using a 5mm axle, and the OD of this bearing is 8mm. It's pretty small just because of the 20-tooth 2mm pitch pulley on this side. And then this side uses a kind of more standard and more durable 10mm OD pulley or bearing. And these get pressed into the wheel, just like that. The 5mm titanium axle gets pushed in here. And then I have 2 nylon washers that go on either side. And this fits into Lynx. Like that. And the side goes on this way. Okay, so I did some tug of war tests. I used a piece of Gorilla Tape between them to tie them together. And I added a roll of masking tape to this one because it's about 100 grams lighter. The roll of tape was 130 grams. So this one ended up to be 30 grams heavier, which isn't that much.
3, 2, 1. Okay. 1. No. 3, 2, 1. Oh man. 3, 2, 1.
After those tests, it looks like the Lego tires have more traction on both the concrete surfaces, and the latex tires have more traction on the OSB and the painted concrete. It's kind of hard to tell which one is better for arenas in general, but I'll end up using the Lego tires just because they don't compress under magnetic force, and with magnets, I'll just have way more traction anyways, regardless of tire compound. Thank you for watching, and thanks to Send Cut Send for sponsoring these robots. Send Cut Send is a great laser cutting service that has a super fast turnaround time, and they carry a wide variety of materials, including titanium and AR 400 and 500 steel.